All right, so for this lesson, we're going to be talking about linear functions, but more importantly, we're going to be talking about the key features. So we're going to be talking about slope and the y-intercept in the real world. Now, we've talked about slope-intercept form, which is y equals mx plus b. So you should recognize that slope is the m value and b is the y-intercept. Now, what you need to know when you're talking about the real world is that the slope is the repeating value. The y-intercept is the initial value. So when I say the initial value, I mean the first one-time number. When I say the repeating value, I mean the number that happens over and over again. So an example of this would be if you go and you get a taxi. So if you go get a taxi, you're going to pay a one-time fee to get into that taxi. So let's say the fee is $5. But you're also going to pay how much you go per mile. So let's say that they charge you $2 per mile. So your linear function, if I have a fee of $5 and they also charge me $2 per mile, that linear function is going to have two pieces. It's going to have the y-intercept and the slope. Well, the fee is something you're going to pay one time. So my initial value is my y-intercept. That is my fee. My slope is my repeating value. We're going to pay $2 every mile, so per mile. So every mile I go, I'm going to pay $2. Every mile again, $2 more. Another mile, $2. That's my repeating value. So my slope is 2. So if I were to write this equation, I would say y equals 2x plus 5. I paid $5 up front, and I'm paying $2 per mile, where x would represent the miles, and the y is going to represent my total cost. So again, just to make sure we understand, x is going to represent the number of miles, and my y is going to represent my total cost that I will pay in the end. Now, please do not get these two things confused. Your y-intercept is very different from your y variable. Your y variable is your total amount at the end. So if we're talking about the cost of a taxi cab, that's your total cost. The y value is your final value after everything has been applied. The y-intercept is the initial value. So they're kind of opposites of each other. The 5 is how much you're going to pay initially. The y is how much you're going to pay at the very end, depending on how many miles you went. So do not get those two things confused. All right, so let's look at some examples, and we're going to identify the slope, the y-intercept, and we're going to write the equation. So the basic shipping charge is $10 for the first item via USPS and $7 more for each additional item. If an equation is made to calculate the shipping charge, what is the value of the slope? So remember, slope is your repeating value. So this is the repeating value. So if I'm looking for the repeating value, I'm looking for the value that's going to keep happening. So we have two options here. We have a first-time charge of $10 and $7 more for each additional item. So the first-time charge, that's a one-time charge. That's not a repeating amount. The repeating amount is $7 more for each additional item. For every item I ship, I'm going to pay $7 more. So my slope in this particular problem is 7. Then it says what would be the y-intercept. Well, the y-intercept is the initial amount, that first time amount. So that's going to be 10. So my equation is y equals 7x plus 10. All right, number 2, I talked about an example just a second ago with this. A taxi service charges a $10 flat fee plus $3 per mile. If an equation is made to calculate the cost of a taxi ride, then what do we have? So we have a $10 flat fee and $3 per mile. So the slope is my repeating value. My repeating value is the $3 per mile. So a good indicator for what is your repeating value are words like per or every or dish for each additional. So those kind of phrases are going to tell me that I'm going to keep paying those over and over. So then my y-intercept is where I'm going to have that one-time initial amount, and that's the flat fee. That flat fee was $10. So my equation for this one is y equals 3x plus 10. All right, for number 3, you're learning yoga in a fitness center, which charges a $200 registration fee plus $12 per lesson. If an equation is made to calculate the total charge you need to pay, what would be the value of the slope? What would be the value of the y-intercept? So we're talking about a $200 registration fee plus $12 per lesson. Well, you're not going to pay a registration fee over and over again. So your registration fee is going to be your y-intercept. That's your one-time upfront fee. That's your initial amount. And then the $12 per session is going to be your slope. That's the repeating amount. Every session, you're going to pay $12 more. That's your slope. So my equation here is y equals 12x plus 200. All right, now that we kind of have where my pieces go and what they mean, let's apply them. All right, so it says Sarah rented a car for X amount of days. The linear equation below represents the Y, which is the total cost that Sarah is going to pay. So X represents the days, so that's important, and Y represents the total cost that she's going to pay for that rental. What is the slope of the line being represented? So if I have Y equals mx plus b, then my slope is 17. So what does my slope mean in this situation? Well, remember, slope is the same thing as your change in y over your change in x. So my slope is going to be my y value. Well, my y value is the cost, so that's the dollars, okay, over my x value, which is days. So my slope is going to represent $17 per day. So she's going to pay $17 per day for that rental. Now, what is the y-intercept? Well, the y-intercept is 130. Well, the y-intercept in the real world is the initial amount. So she's going to have to pay $130 up front. That is her flat fee that she's going to have to pay. That's that one-time fee that she's going to have to pay in order to rent that vehicle. So she's going to pay $130 up front, and then she's going to pay $17 per day. And then depending on how many days she rents it, X is how much she's going to pay total, which is Y. All right, let's look at the next example and let's apply it. It says, at the car rental company, you pay a flat rate of $113 and then a daily fee of $12. So we have a flat rate of $113 and a daily fee of $12. Write the linear function for the total cost Y for renting it X days. What is the cost of renting it for 3 weeks? So we're going to write the equation and then we're going to use the equation. So my equation here, I have the flat rate is my one-time fee. That's my y-intercept. My daily fee of $12 per day is my slope. So my equation is y equals 12x plus 113. Now, let me remind you that this problem said a daily fee. So my x represents days, and my y represents the total cost. So they want us to figure out how much it's going to cost for 3 weeks. Well, we can't plug 3 weeks into a day problem. So we're going to have to convert 3 weeks into days. Well, how many days are in a week? Well, there's 7 days in a week. So if there's 7 days in 1 week, 7 times 3 is going to give me 21 days. So what we're going to do is we're going to take that 21 and we're going to plug it in for X. All right, so if we calculate that, we should get 12 times 21 is going to give me 252 plus 113, and I got 365. So it's going to cost her $365 to rent that vehicle for 21 days. All right, so let's look at this example. It says a pool has 2,000 gallons of water currently in it. You begin to empty the pool, and after 2 hours, it has drained 20 gallons of water. So what I want to do is I want to write the equation, and I want to graph it, and then I kind of want to look and see what's going on with it. Okay, so we have 2,000 gallons of water. That is my initial value. I know how much I have initially. That's 2,000 gallons. Now, you are going to empty the pool. So that means that the water is going to go down. So it's going to have a negative slope because it's being emptied. But what is the slope? Well, it tells me that it's emptying it by 200 gallons over 2 hours. So if I do 200 divided by 2, because it's the change in y over the change in x, that's going to give me 100 gallons per hour. So that's going to be my slope. So my slope is going to be negative 100 because it's going down. So my y-intercept is y equals negative 100x plus 2,000. Now, I will say this, that a lot of times in math, formatting wise, people don't like to put negatives in front. I don't know why, but it happens a lot. So they'll actually rearrange that so that the negative is not in front. So they'll put 2,000 minus 100x. It's the same thing. They just, for some reason, don't like the negative in front. I'm okay with the negative in front, but just be mindful if it's something that's multiple choice, they may write it like that. So let's graph this. Well, we're going to start by plotting the y-intercept. So my y-intercept is at 200. So let me put some tick marks here. So I'm going to start at 200. That is my initial value. Now, I'm only using quadrant 1. Why am I only going to use quadrant 1? Because quadrant 1 is where it's positive. We can only use positive values in the real world. So in quadrant 1, we start at 2,000, and we're going to go down by $1,000 every hour, or excuse me, not 1,000, 100 gallons every hour. So we're going to estimate a little bit. So we're going by twos. So we're going to go halfway in between, and we're going to say we're going down to 1,900. Well, how do I know I went down to 1,900? Well, if I think about this, so at 0 hours, I had 2,000 gallons in my pool. So hours and gallons. Now, after 1 hour, it went down 100, so we have 1,900 there. After 2 hours, it's going to go down another 100, which is 18. So at 2 hours, I'm going to go plot 18. Then at 3 hours, we're going to go plot 1,700. And this trend would continue. Every hour, we would go down until we emptied our pool. And that's just something to think about. So we have that initial value 200, but it's going down because it's emptying. So that slope is going to be negative. This has a negative slope. All right, so let's look at these problems right here. So it says a membership to a gym costs $25 per person in 1995. The membership cost has increased by an average of $6 per person for each year since 1995. Write a linear equation for the cost of the gym membership since 1995. What is the cost of the membership in 2009? So normally when I present this problem, students get confused because they see a lot of $25 per person, $6 per person, and so forth and so on. But you still need to ask yourself, what is the initial amount? Well, the initial amount is the cost in 1995. So my initial value is going to be $25. That initial membership fee was $25. Then as the years increased, the membership increased by $6 per year. Okay, so that $6 per year is my slope. So my equation is y equals 6x plus 25. So let me explain it one more time. The membership fee started out as $25 in 1995, but every year it increases by $6. That's the repeating value. So what they want us to do is they want us to calculate how much it's going to cost in 2009. Well, in 2009, I'm not going to plug in 2009 because plugging in 2009 is like plugging in 2009 years. We're not calculating 2009 years. What we aren't calculating is how many years since 1995. So we need to find the difference. So if we take 2009 and we subtract 1995, we should have a 14-year difference that we're trying to calculate. Okay, so X is years and Y is going to tell us how much the membership is. So we're going to take our problem. So we're going to, where X is, we're going to plug in 14 because we're calculating 14 years. All right, so 6 times 14, that's going to be $84. So over that 14-year time frame, it increased by $84, but it was initially $25. So 84 plus 25 is going to give me a membership fee of $109 now in 2009. All right, so anytime they give you the year that it started and then they give you a year that they want you to calculate, you need to make sure you subtract the years, okay? All right, so then we have some graphs and they want you to interpret. Now, these are very common, especially on final exams. So be very careful with these and pay very close attention on what they're asking you for, because there are correct meanings in these problems, but did you give the meaning that they're asking for? So it says the graph below shows the cost of a long distance calling plan. So let's look at this graph here. So on this graph, we have minutes, okay, and we have the total cost in dollars. So this calling plan, so let's say, obviously right now we all have cell phones where most of us have unlimited minutes. That's not necessarily the case that it always was. You used to have to pay an initial fee, and then you would pay so much per minute that you talked for a long distance call. So right here we have 5. That is the y-intercept. So we know that that calling plan has an initial amount of $5. Then we know that it's going to increase. So that calling plan is going to increase for how many minutes you talk. So it's going to go up by $1 every 4 minutes. So my slope is going to charge me an additional $4 per minute. Now, I calculated all this and I looked at it based off the graph, but really it's just asking me to interpret the y-intercept. What does the y-intercept mean? Well, when I think y-intercept, I should think initial value. They're not asking me to determine that the initial value is 5. They're asking me what is the meaning of the initial value. So is the initial value the phone service fee, the cost per minute, the total cost, or the number of minutes $10 can buy? So when I look at this, the phone service fee. So the phone service fee, so there's your key word right there. The fee is going to be your upfront amount. That is going to be your initial value. That is your B value. The cost per minute, that's how much you're going to pay for every minute. That's your repeating value. That's your slope. The total cost, remember, that's your Y value. Anytime you talk about total, that's the Y value of the equation, the Y variable, and the number of minutes that $10 can buy. Well, we're not asking how much, we're just talking about how much is upfront. So my upfront amount is the phone service fee. All right. So the next one, it says Roman is adding water to a swimming pool. So we talked about a swimming pool that was losing water. Now we're going to add water to it. The graph below shows the amount of water in the pool as more water is added. So this time it asked me to determine the slope. So when we talk about slope, remember we're talking about the repeating value. So the initial value would be how much water was already in the pool. But now we're going to talk about the slope. We want the repeating value. So the repeating value, let's look. That's going to be, we have time in minutes, and we have water in gallons. So that repeating amount, if we're talking about how much is repeating, we're talking about the slope. So slope is your change in Y over your change in X. So we're going to talk about the change of gallons per minute. So let's look for which one says gallons per minute. So A, the additional gallons of water added per minute. I would agree with that. Then we have the total time needed to fill the pool. Well, we don't want to figure out how long it's going to take to fill the pool. We just want to know what the slope represents, which is the repeating amount. the amount of water in the pool before any water is added. So the amount before any water is added is going to be your y-intercept. That's the initial amount. That's your B. We don't want to find the B though. And then the total amount of water needed to fill the pool. Well, that's the same thing as B. So we're talking about gallons per minute. So the answer is A. All right, so again, 2 things to remember. So I'm going to go back to my slide. When we talk about the slope and y-intercept, the y-intercept is the initial value. That's your one-time initial amount. Your slope is your repeating value. That's the amount that you're going to keep paying over and over again, okay? So keep that in mind, and this is a big section. It's very important, so please make sure you learn those 2 things.